Dear students, in this video you are going to learn about Unit 4 short answer questions with answers. Question number 1. Define the fan out of a digital logic family. Fan out is defined as the number of inputs a logic circuit can drive at its output. A good logic circuit should have a large fan out value. For TTL it is low and for CMOS it is high. Question number 2. Obtain the gray code of a binary sequence 11001100. So now let us say binary code equal to B7, B6, B5 up to B0 and a gray code G7 to G0. Then conversion process, G7 is B7, that is 1 in the given sequence, from the given sequence. G6 equal to B6 exclusive OR with B7, that is 1 exclusive OR with 1, it is 0. And G5 is B6 exclusive OR with B5, so 1 with 0, it is 1. And G4 is B5 exclusive OR with B4, therefore 0 and 0, it is 0. And G3 is B4 exclusive OR with B3, so 0 and 1, it is 1. And G2 is B3 exclusive OR with B2, so 1 and 1, it is 0. And G1 is B2 with B1, so 1 with 0, it is 1. And G0 is B1 exclusive OR with B0, and it is equal to 0 exclusive OR with 0, which is equal to 0. Finally, the gray code is 10101010. Okay. Third question. List the voltage levels of a voltage levels of logic 0 and logic 1 in TTL and CMOS families. And logic voltage levels will be differing. And now voltage levels in TTL, logic 0 is 0 to 0.8 volts and logic 1 varies from 2 to 5 volts. And in CMOS, logic 0 is from 0 volts to 1.5 volts and logic 1 is from 3.5 volts to 5 volts. Okay, good logic levels we obtain in CMOS. Question number 4. Obtain the binary code of a gray code sequence 10101010. Let us say gray code equal to G7 to G0 and a binary code equal to B7 to B0. Okay, and then let us see the conversion process. B7 equal to G7 equal to 1, B6 equal to B7 exclusive OR with G6, that is 1 with 0, it is 1, different values 1. And B5 is B6 exclusive OR with G5, which is 1 with 1, it is 0. And B4 is B5 exclusive OR with G4, it is 0 with 0, it is 0. And B3 is B4 exclusive OR with G3, it is 0 with 1, it is 1. And B2 is B3 exclusive OR with G2, so it is 1 exclusive OR with 0, it is 1, different values 1. And B1 is B2 exclusive OR with G1, so 1 with 1, it is 0. And finally B0 is B1 exclusive OR with G0, which is 0 with 0, which is 0. So binary code finally we can say 11001100. Okay, then let us see the next question, that is define the propagation delay of a logic family. Right, propagation delay, let us see the time taken by the logic circuit to change its output when the input is changed. And it is measured in nanoseconds, and a logic circuit with less propagation delay is expected always, and a logic circuit with less propagation delay will operate at high speed. Therefore, propagation delay is inversely proportional to operating speed of any circuit. Then next question, question number 6. Define the noise margin of a logic family. Let us see what is noise margin. The ability of the circuit to tolerate unwanted voltages, that is noise, without affecting its output, that is called noise margin. A good logic circuit should have high noise margin and it is measured in volts. Question number 7. Write the truth table and Boolean expression of a 2x1 multiplexer. And we know 2x1 multiplexer, it has many inputs and single output, and it is 2x1, that is 2 power 1 inputs and 1 output and 1 select signal. So number of inputs equal to 2 power 1, that is 2. Number of select lines n, that is 1, and output equal to 1. Okay, truth table if you see S and Y, S 0 and 1, 2 possible inputs, and Y when S equal to 0, I0 will be transmitted, and when S equal to 1, I1 will be transmitted. You can write the Boolean expression for Y equal to S bar I0 plus S I1. So when S equal to 0, I0 is transmitted, and when S equal to 1, I1 is transmitted. Next question, if the message to be transmitted is 111, 0111, 01, define the status of even and odd parity bits. We know what is a parity bit, and now let us see, let message bit equal to the given data, that is 111, 0, 111, 01. Now what is even parity? Total number of ones including message bits and parity bits must be even, then we say it is even parity. Now here we have 7 number of ones, therefore 7 is odd number, therefore even parity bit should be equal to 1. Similarly, what is odd parity? Total number of ones including message bits and parity bits must be odd, and here we have 7 ones, that is 7 is odd, therefore odd parity bit is 0, right? And like that we can define what is parity bit. Now next question, 9th question, that explain how an exclusive OR gate can be used as a buffer and as an inverter with the help of fixed input. Okay, now let us see, an exclusive OR gate, it can be used as both buffer and also inverter depending on how one of its input is fixed. First let us see exclusive OR gate as buffer. You can see exclusive OR gate and one input is A, second input is connected to ground and Y equal to A. Let us see now. Now to use the exclusive OR gate as buffer, fix one input, one of its input to 0, that means B input is connected to ground. If input A is variable, B is fixed at 0, then what happens? Output Y equal to A exclusive OR with 0. So A exclusive OR with 0 is equal to A. If A equal to 0, 0 to 0 is 0, and if A equal to 1, 1 exclusive OR with 0 is 1. Therefore we can say Y equal to A exclusive OR with 0. Y equal to A exclusive OR with 0, therefore it is equal to 0. This means the output follows the input just like a buffer. Now let us see exclusive OR gate as inverter. To use the exclusive OR gate as inverter, fix one of its input to 1. And you can see this logic symbol here, A equal to input is connected and other input is connected to 1. And Y equal to A bar we will get. If input A is variable, B is fixed at 1, then the output Y equal to A exclusive OR with 1, that is not of A. You can see exclusive OR gate here as mentioned. This means that output is a logical complement of input and it acts as a inverter. Next question, write the Boolean expression and truth table of 1-bit comparator. So comparator, it compares A and B to 1-bit data, and A greater than B, A less than B, A equal to B. So A B 0 0 0 1 1 0 1 1, and A greater than B means 1 0, less than B 0 1, and equal to B first and last terms. And you can see A greater than B means where it is 1, that is A B bar, and A less than B is where output is 1, that is A bar B, and Boolean expression for A less than B is A bar B, and A equal to B, it is AB plus A bar B bar, that is A exclusive NOR with B. So like this you can write all short answer questions, and you can also elaborate some of the areas where what we have discussed in our regular classworks. Okay, wish you all the best. Thank you.